Construction products constitute energy-intensive systems during their whole life cycle, comprised of energy-demanding operations, but most importantly, the occupants, which are the building's driving operational force. Extensive industrial practice verifies that even though more than 80% of a building's total energy consumption occurs during the actual building operation phase, ultimately this measure is mainly defined by critical decisions made during the early design phase. Undoubtedly, architects, designers and engineers need tools that will assist them in creating better and more sustainable buildings, equally addressing the main variables affecting building performance, including the most critical factor of occupancy.
Adapt4EE is a STREP project funded in the context of the 7th Framework Programme's objective on ICT solutions for energy efficiency. The project aims at augmenting the contemporary architectural envelope by incorporating business and occupancy-related information into a single integrated building information model. Adapt4EE will further extend today's building performance simulation practices, providing a holistic approach to the planning, design and evaluation of energy performance of buildings at an early design phase and prior to their realization.
Building occupants are at the heart of the Adapt4EE project, which focuses on offering architects and engineers tools that will assist them in creating more sustainable construction projects, even from their early design phase. Within this framework, Adapt4EE attempts to capture accurate real-life occupant data and introduce them in a highly accurate building energy performance simulation environment. Monitoring and reproducing visitors' activity and movement within buildings, accurate alignments of building spaces with the business processes taking place within their boundaries, and interactive simulations offering the opportunity to architects and engineers to experiment with alternative designs and visually understand the impact of their decisions to the building energy efficiency, business performance and occupants' comfort are among the main research results that have been achieved by the Adapt4EE project.
The goal of the Business Process Model and Building Information Model Alignment and Integration module is to develop detailed business process models for the pilot domains based on interviews and analysis of the pilot site processes, and subsequently identify and extract skeleton activities. Skeleton activities are actually sets of abstract and parameterized activities that can be reused in different buildings of the same domain, such as activities that are performed in all hospitals. The approach was to take specific pilot site business process models, analyze and make them more generic by identifying and aggregating activities to develop sets of skeleton activities and then integrate them with the building information model.
The occupancy extraction system utilizes a number of low-cost privacy-preserving sensors of different types installed into the building feeder. The sensor used by the system can provide not only information about the exact building occupancy, but also the occupancy per space, occupancy per zone, in conjunction with other sensors that at the same time measure corresponding energy consumption. All these sensors can measure several attributes of the building environment: global energy consumption per type, such as lighting, HVAC, equipment, etc., energy consumption per space, energy consumption per zone, carbon dioxide, temperature, and finally occupancy per building, per space, and per zone. Smart depth sensors, which are calibrated to a global reference coordinate system, provide depth images to the occupancy detection and extraction system. Occupants light in the monitoring area are located, exploiting dynamic adaptive background modeling, and they are tracked by an aggregation tracking module. The image-based occupancy detection and analysis module is comprised by 4 sub-modules. The first one is the camera module, which is responsible for handling the depth sensors and for updating the dynamic adaptive background model. The second one is the calibration module, which estimates the transformation of each depth sensor output to a global reference coordinate system. The third one is the detection module, which detects the occupancy from the depth images acquired by depth sensors. And finally, the tracking module tracks the detected occupants and extracts the occupancy statistics.
Each partner in Adapt4EE brings different technologies, different experiences, which were developed in maybe different contexts, so they never were thought of to work together. And now we have this new project where we want to bring all of these technologies together, and they don't speak each other's language, so how to solve this problem? We just put in the middleware developed at Fraunhofer FIT. It's the LinkSmart middleware. And all this does is to translate between the languages and the message formats of these different components, thus ensuring that they can communicate with each other and avoiding repetitive changing work on all the models that have been developed thus far.
The Adapt4EE building simulation environment allows architects to simulate a profile for a specific domain, hospital, office or factory, into several profiles of different buildings or different variants of the same building, with, for instance, different refurbishings. The domain-specific profile specifies business processes, occupant behavior, and equipment usage, and contains knowledge derived from on-site sensor measurements in real-life settings. The building profiles contain a 3D model of a building and combine it with information about the equipment present in the building, the power consumption of lighting, HVAC and equipment, and information about the surrounding environment, such as temperature, humidity and sunlight. The simulation environment executes simulations by means of an ecosystem of semantic software agents. Such agents keep an individual knowledge base about their environment, interpret messages they receive from other agents, and act according to the beliefs present in their knowledge base. The semantic agents representing occupants have been trained throughout several domain-specific trainings to behave similar to real actors active in the domain. These trainings are based on real measurements of occupant presence and movements, environmental temperatures and CO2 levels, and energy consumption by means of several types of sensors in reference buildings.
The Visual Analytics module supports the analysis of large volumes of space occupancy and energy consumption data. This allows the detection of spatial temporal patterns that are important for energy consumption optimization. In particular, the module allows the user to compare historical space occupancy data to energy consumption data in order to validate and possibly initiate changes in the energy management policy. The module allows the analyst to process data in different temporal resolutions and with different temporal filters as assisting him to detect patterns that may be difficult to detect otherwise. Moreover, the Visual Analytics module supports design and energy management decisions by visualizing the results of simulations on energy efficiency under different design decisions. To do so, it includes a variety of techniques and components that allow the visualization of key performance indicators. The visualizations, along with the KPIs, allow the identification of problematic design decisions in terms of energy, business performance, and comfort level. Furthermore, the Visual Analytics module supports the customization of the simulation reports by choosing and/or filtering the desired outputs based on the needs of each end user. The module offers a variety of filters that allow the end user to create custom reports and so to easily recognize problematic areas with regards to building performance and better shape and compare the performance of design alternatives addressing these problems. Finally, the Visual Analytics module facilitates the detailed spatio-temporal analysis of building performance in terms of energy consumption, building performance, and occupancy comfort, and exploits innovative data mining techniques and mechanisms to allow the end user to identify patterns, outliers, and correlations between conflicting factors of building performance, thus assisting him to further optimize the building design and resulting performance.
The Clínica Universitaria de Navarra is one of the pilot sites where the Adapt4EE solutions will be tested and validated. The clinic employs over 2,300 professional staff, with facilities providing healthcare, education and research services and activities. The clinic carries out over 130,000 patient consultations and formalizes over 13,000 hospital admissions annually, while offering hospitalization to over 500 patients on a daily basis. One of the pilots will be based on Estadio Citadia de Coimbra, which is a multi-purpose stadium that currently supports a wide variety of events such as sports, entertainment and music concerts. The stadium also contains a large number of commercial and office spaces which are rented to more than 20 tenants.
Adapt4EE adopted a phased approach for pilot installations in the project's pilot sites so that unexpected problems during the installation could be detected and handled before the large-scale deployment. For testing purposes, the preliminary deployment took place at ESA and CERT. At ESA, a small set of energy meters, environmental and RFID sensors were installed in order to test their interconnection with the Adapt4EE middleware. A similar approach was followed at CERT in order to test the performance of the depth sensors and their interconnection with the Adapt4EE framework. Taking into consideration the adopted approach, the initial deployment took place in the pilot sites prior to the end of the second year of the project, followed by a period of testing, refinement and expansion. A second phase deployment took place during the first month of the third year of the project, also followed by a period of testing and consolidation. Preliminary evaluation and training activities started at the end of the second phase of deployment, with the enlarged pilots implemented before the end of the project.
To support evaluation activities, the project organized an international seminar and workshop on building energy performance simulation, hosted by Universidad de Navarra in Pamplona on October 2014. The international seminar and workshop focused on the demonstration and testing of alternative building energy performance software tools and their comparison with the Adapt4EE project solutions. The aim was to evaluate the advancements brought by Adapt4EE against the needs of different actors, such as architects, engineers or facility managers, towards accurately evaluating the energy performance of buildings from their early design phase.